Okie doker. It's time to lock it in. Let's start learning. Need some chippos too. Okay. Oh no! The bag was ripped a little on the other side, so it started pouring out. Okay. Take this off. I'm not reading. Okay, oh. Come on. Come on with it. Please? Okie doker. Alright, let's go. So some random shit. We're simulating it because computers. I mean, how many artificial factors could you have and have an algorithm to pick a random number in there by like picking one and then adding and doing enough stuff to it and not doing the same thing but doing the same thing and then merging? I don't know. Seems like it'd be maybe not too bad to do like semi-random for what a human. Well, it seems like it'd be pretty easy to make something that a human would probably, that your average person would think is pretty random, but it's probably missing some key things like natural sequences of numbers. At some point, you're gonna have a sequence where you get like fucking 50 of the same thing in a row. You're gonna get heads 50 times in a row, and that's gonna be more random than heads, tails, heads, tails, heads, tails forever. So. But it's certainly possible to make something that is more random than how random 5, 5, 6, 7, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 feels to a random person. It doesn't feel very random. Hmm? Yeah, sort this list, bro. This array. Three, four, five, yo. Never mind. Sorry. We're incrementing before printing. Whoops. I didn't see the return. Yep. Yep, because that will be staticking. I was thinking about a use case for static variables because I haven't really used them personally. I don't think I've made an example. Like when making examples for things, I haven't done that with static variables yet. For one, like a multiple choice question or testing out header files and stuff, I haven't done static variables for anything. But they've said that the creating of the variable doesn't cost anything. It's the assignment. So creating a static string, standard string, in order to only be assigning new stuff to it, instead of having to create it and then assign it and then create it and then assign it, instead it would just be assigning it. The assigning is where all the computation comes from. So we're not copying it or anything. So it wouldn't make sense to do a static variable. It's the same shit. Because removing the cost of creating isn't removing any cost. Because the cost of creating is 0. We're just finding somewhere else in memory and saying, there. And then we do shit to it. Uh-huh. It's technically value initialized at first. Static. Or 0 initialized. Yeah, it's stateful because it's static. Yeah. It's like a sort algorithm, likely stateless. We don't give a fuck about previous shit we sorted. Stateless means there aren't any stateful variables, bro. We're not storing anything between calls. Nothing is retained across calls. Okay, we have a current state and then we fucking change it. It's the same way. If given the same input, yeah. Given the atoms in this location, the output, the end result 10 years down the line is the same no matter what. If everything was in the same, assuming that the environment is deterministic. Pale. Backslash T, is it tab? I guess so. Yeah. I really likes 3s and 6s and 7s. Oh, gotcha. Oh yeah, because you're at least having, well, assuming that the state is, oh well, it actually starts as 0. Oh, and it's unsigned too. Yeah, and if it's because so if it's unsigned, it's especially if it starts at 0 too. Oh yeah, so these are only positive anyways. Excuse me, even if it wasn't unsigned, because we're only multiplying and adding positives. Well, if it was signed, then eventually, if we added enough, it would overflow and become negative. So you get like 4.3 billion plus 1 is negative 4.3 billion. Bro, it's overflow. Yep, so you get a number, add some big ass, or sorry, multiply it by some humongous shit, and then add some other shit, and then overflow some more, and then boom, 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 and then take the remainder of it and something else. Who the fuck knows? Which means the numbers have to be smaller than that. Yeah. Because if more than this is remaining, then we can divide it by that one more, and then whatever's left is the remainder. So, okay. Then we return it, and then we save them, and then we modify them, and then we lose them, and a bump, and a bump, and a bump. Okay. Next one, return. Next one, return. Next one, return. And because this guy was 0, he was static because we're saving the crazy ass number, and then we're adding some shit to it, and then we're multiplying, and then oh, it feels pretty random. Basically one line, 2 lines, because we definitely have to store it. So 3 lines of code basically. Persistent number, static number, modify it, return it, and then just do that a bunch. But we don't even need to do that a bunch. We could just do it, and that's the random number. 3 lines. Pretty good. Seems biased towards the higher numbers than the smaller. Because it should be from 0 to this. And there's like way more, probably 70%, if not more, are over 10,000. Which doesn't make sense. It seems pretty damn unlikely for a set of 100 numbers. Okay, so we could do pseudo random number generator, so PRNG. And we basically just do some big shit to it, do wraparound, do unpredictable-ish kind of stuff that is tougher to predict, therefore more approximately random. And in this case, this is a stateful function. Set to a 0, we modify it. Yes, so technically you could still predictor. Yep, modified. Yeah. Meaning this algorithm is similar to the last one in that our current state, we do something, we return. Done. Or rather, we do something to a current state and return it. Do something and return a current state. That's it. Modify the current state, then return. Oh. Also true. Oh, and it's because if we take the remainder, that the remainder of an even number, maybe that means that there's an odd the next time, and then it's flippy. Makes sense. Seeding. Oh yeah. 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 Yeah, that states all that is well, the state determines the end state. The initial determines the final. Or just later. Called a random seed. Oh yeah. So just like in Minecraft. Huh. Okay, so at first we have an unsigned number and we get a seed value. And then we seed it and generate 10 values. Okay? We seed it, so we do seed period n. And then we print 10. And print 10 is basically a helper function that goes and gets the random number and prints them 10. So at first we're seeding. So we're just taking this seed, the argument here, and passing it. And it is unsigned at first, so no overflow there, so we can't start with a negative. Okay, so we're storing it. And then, 10 times, because we're going up through 10. We are outputting a number. And the number, same shit as earlier. Yep. Note this says casually, not causally. And all we're doing is modifying it. So in this case, we have a printing function to output the shit, a calculating function to get the number, and we're storing the seed somewhere in case maybe other places want that seed. Same seed value, 7 and 7. We get the same shit. Yes. We're adding 5, multiplying by 2, and dividing it by negative 16. We start with 9 every time. We get the same shit every time. Because we're doing the same steps every time. Mm-hmm. Makes sense? Yeah. Mm-hmm. Yep. Oh, a seed generation algorithm. So maybe it produces what? Sufficiently large or sufficiently varied numbers so that it makes the PRNG seem like it's more random? Yeah, because it's just 2 to the 128, bro. Because 2 to the 0 is 1 bit, so it just goes on. Are you sure it's not 2 to the 127? If you have 128 bits, your first is only 0. Seems like that's the correct answer. Oh, it's 30 minutes.